Okay, now we are going to work on the stem and leaf plot. This is the last way of the visualization or presentation of data. And after this, we have examples only. And you can see in this slide, we have a lot of information to capture before we plot the stem and leaf graph or stem and leaf plot. So let's begin with the definition of stem and leaf plot. So a stem and leaf plot is a data plot that uses part of the data value as a stem and part of the data value as a leaf to form group or classes. So here, when we say stem and leaf, for every number, say for example, 52, okay, for 52, also I have one example down here. Let me take the same example. I use 23 here. For example, in 23 has the stem 2, okay, and leaf 3. So the last digit, you can see this last digit is the leaf. Last digit is the leaf, and this one here is stem. So what we do is we use the part of the data value as stem and the other part of the data value as leaf. So the last digit is leaf. For example, here in the other one, 432, you can see in 432, the last digit is the leaf. Leaf is 2. And then 43 is your stem. So we use part of the data value as a stem and part as a leaf. But more specifically, the last digit is the leaf. Any question there?
No.
If you have,
I have a question.
yes.
Why they do that?
So, okay, why? We are going to see that in a minute, because why, answer to why is here, because this is useful to visualize the distribution of a small set of data. If it is a small set of data, we'll be able to visualize the data easily. And also, by drawing the stem and leaf plot, it is easy for us to talk about the direction of skewness, like whether the data is skewed to the left or is skewed to the right, or it is normal. In histogram, we can easily see whether the data is skewed to the left, right, or normal, but we use the histogram for a large set of continuous data. But for a small set of data, stem and leaf plot is effective. That's why, if you can mute yourself, that will be wonderful. Okay, so for the small set of data, it is easy to visualize the data and look for the skewness in the data, so we use this. Could you please mute?
Less than 3 hours?
Okay, so as I was explaining you, the stem and leaf plot is the visualization of quick data or a small set of data. So we use the stem and leaf plot. There is nothing besides that, but it is quick and easy for a small set of data. So we use the stem and leaf plot. Let's take an example on how we can create the stem and leaf plot. So here we have this small set of data. You can clearly see in an introductory statistics class at CCA, 10 students scored the following scores in midterm exam. Create a stem and leaf plot to show the above scores. So here you can see that the data given, you have 76, 78, 80, 83, 88, 88, the 90, 92, 94, and 100. We have these values. So we have to draw the stem and leaf plot. So first what we do is we draw a vertical line to separate the stem and leaf. So to the left of this line, we'll have the stem, and to the right, we'll have the leaf. So for these two numbers, for 76 and 78, what is the stem?
7.
7 for both. And here we'll write the leaf. So leaf for 76 is 6,
Mhm.
and leaf for 78 is 8. So this line represents 76 and 78. So this is one class, okay, 76, 78. Now next we have the data in 8 is here. So for all these data, what is the stem?
8.
8. 8, okay. And for 80, your leaf is 0. For 83, what is the leaf?
3,
3. And for these two 88, what is the leaf?
8.
8. And there are 2 of them, so we'll write 2 of them. 8. Okay. And after that, we have 90, 92, 94 here. For all these, what is the stem?
9.
9 is the stem. Okay. And
0,
then, yes, the leaves
0,
are 0 to 4.
0 to 4.
0 to 4. And for the last number here, what is the stem?
10.
10 is the stem. Very good. 10 is the stem. And what is the leaf?
0.
0.
0. Okay. So this is how we can create the stem and leaf plot. It is not that difficult. We just write the last digit as the leaf and everything else as a stem, and we create the stem and leaf plot. And if you look at this one, see, you don't have to draw this, but if I draw the curve along these numbers like this, you can see the distribution. That's not looking good. Let me do it one more time. Look at that. And if you try to visualize from this side, if you look from this side, it looks like the distribution curve, right? Look at that. And you can see that this is the tallest bar or tallest data value or the largest class, whatever you call it. From here, when you draw the curve, it is pretty much equally spread on both sides, right? Can you see that?
Yeah.
Okay, so meaning of that is this distribution is approximately normal. Okay, this distribution is, let me write, approximately normal. So for the quick visualization of a small data set like this, like 10 data set here, we use stem and leaf plot. It will tell you in what direction the skewness is, if there is any, or we can easily look at the data and tell whether it is normal or not. So that is the main goal of creating the stem and leaf plot. Any question on that? Okay, I think there is no question. You have a question?
Yeah.
Okay, what is it?
What if it is like more than 3 digits? Do we have to pick only the 4th or the 5th digit as a leaf?
The
Or
last, yes, the last
just
significant
only
digit
one?
as the leaf. Yes, only one as leaf, yes.
Okay. Thank you.
Any other question?
I have one question about
Yes.
100.
Uh-huh.
Like we said, for 432, the
Say, for
stem is
example,
40. Yeah, the stem is 43 and the leaf is 2. Okay, that's right. Thank you. Got it.
Yep. Okay, so we'll move forward now. Now we have few examples from this chapter. So the first example here is use the following frequency distribution to answer the question that follows. So here we are looking at some simple examples based on what we have studied so far in the chapter. So they have given the class and frequencies. So the classes here are 50 to 55, then 56 to 61, 62 to 67, 68 through 73, 74 through 79. You can see that it's not a continuous data. From 55, we jump to 56. From 61, we jump to 62. From 67, we jump to 68. So we have a difference of 1. And here our focus is on third class only. See, we are looking for the class boundary for third, midpoint for third, and class width for third. So this is our third class here. So what are the class boundaries for the third class? When we say class boundary, we try to make the data continuous. So here we have 61 and here is 62. What is the difference between 61 and 62?
1.
1, right? Okay, 1. And we divide that 1 into two parts. 1 divided by 2 is how much?
0.5.
0.5. So 62 minus 61 divided by 2 is 0.5. So the class boundary, the idea is we subtract 0.5 from here, from the lower boundary, and for the upper boundary, we add 0.5. So what is 62 minus 0.5?
61.5.
Yes, 61.5. And what will be the upper boundary when you add 0.5 to 67?
67.5.
Yes, 67.5. So the class boundaries are 61.5. Let me rewrite that. 61.5 and 67.5. Okay, so if we do that, like here, if we start from the beginning, this will be 49.5 up to 55.5. And if you subtract this, it will be 55.5 up to 61.5. So when you end here at 55.5, you'll begin here at 55.5. So the data will be continuous and we can easily create the histogram. So that is the idea of class boundaries. The reason we make the boundaries or we create the class boundaries, that is for the construction of histogram. Any question there?
No.
Okay, no question. So now the modified class, this class get modified to 61.5 to 67.5. Okay, now what is the midpoint of the class? See, here we are asked to find the midpoint of the class. Whenever we are asked to find the midpoint, we have to add the boundaries and divide it by 2. So the midpoint will be 61.5 plus 67.5 divided by 2. So in your calculator, add those numbers, 61.5 and 67.5. 61.5 plus 67.5. What do you get? Is it 129? And divide that by 2. I got 64.5. Did we get that?
Yeah.
Yes, no?
Yes.
Yes. Okay. So that is the midpoint of the class. So the value which is in the middle of 61.5 and 67.5 is 64.5. That is the middle point. Okay. So if you remember, to construct the frequency polygon, we need those midpoints. Okay. Last one is class width. Class width, how long is the class? How wide is the class? So that is, we have to find how many units are there when you go from 61.5 to 67.5. So technically what you have to do is you have to subtract the lower boundary from upper boundary. So it is 67.5 minus 61.5. How much is that? 67.5 minus 61.5. What did you get in your calculator? Is it 6?
6.
Okay, so that is the width of the class. Okay, so we have used this before when we are working on the construction of histogram or the construction of frequency polygon. But we have a quick question here where we are asked to calculate those 3 little things. Any question on this example?
Yes, I have a question.
Yes.
Is the class of the boundaries and the midpoint always divided by 2?
So whenever you want to find the midpoint, yes, you have to add the boundaries and divide it by 2 because we are looking for the values in the middle. So always add the boundaries and divide it by 2. Yes.
Okay, and the same with the boundaries. You always add the 61 and the 62. I mean, you subtract those and then you divide by 2 always.
Yes. So we subtract these two numbers, the adjacent numbers, and then we divide it by 2. And whatever we get, here we got 0.5. So we subtract 0.5 and add 0.5. But after subtracting this, if we get 1, then we have to add and subtract 1. So whatever result we get, we have to add and subtract that.
Okay, thank you.
Any other question? Look like it's no. So we'll go to next example. Okay, here is the other example. And here, let's see what we are asked to do. In A, we are asked to use the ogive given below to approximate the sample size. If you remember when I was constructing that ogive, we say that this ogive will give you the total number of observation directly even when the data set is not given. So here is the tip of that ogive given here. What is the cumulative frequency corresponding to that when you come along that towards the y-axis? From here, if you move towards the y-axis, what is that cumulative frequency?
80.
80. So what is the total number of observations? 80, right? So the total number of observations is 80. That is the use of ogive. That's what we have studied. Total number of observations, or total sample size, which is same as the sample size. Okay, sample size is n equal to 80. Any question on that? No? Okay. B now. In B, we are asked to use the histogram to estimate the total number of adults in the ZIM. So this is about the number of adults who went to ZIM, and then the frequency is given based on their heart rate. That's how they are measured. So what we have to do is, by looking at this, we have to find the total number of observations. So first, if you look at the first bar here, this bar, what is the height of that bar? Please look at it carefully and give me the estimation. See, this is estimation. You may or may not be able to find accurate because the data is not properly labeled. That's why the word estimate is there. What is the height of the first bar?
I'd say 3 or 4.
3 or 4. Let's do 3. I think it's 3, something like that. I just don't want to debate with that. 3, I'm taking 3, if you don't mind. What is the height of the second?
15.
15. Okay, we'll take 15. What is the height of the third one?
27.5.
27.
27. Okay, it will not be 27.5 because we are talking about the number of adults. So a human being cannot be 27.5. So we'll take 27. I hope you don't mind that. How about the height of the next one? How tall is that?
42.
42. Okay, 42. What is the height of this one here?
30.
30. What is the height of the next bar?
20.
20. Okay. And what is the height of the last bar here?
5.
5. So your n is equal to sum of all that. So 3 plus 15 plus 27 plus 42 plus 30 plus 20 plus 5. So what is n equal to? Please add in your calculator. I'm also going to add. So we have 3 plus 15 plus 27. I'm adding on my calculator. Make sure you try so that you know that whether I'm doing it right or wrong. We can check ourselves. I got 142. Did you get that?
Yes.
Okay, so the total number of observations or total number of adults who visited the ZIM is 142. So if you remember the way I was constructing the histogram or bar diagram, I used to write these numbers on the top. So if these numbers are there in the top, it is easy to add. If the numbers are not there, you have to read the graph and find those numbers. And by adding those numbers, you will get the total number of observations. Question on that, if any? No question, okay. So in this example here, let's see what we are asked. We are asked to state the shape of the distribution for each of the following. So if you remember the shape of the distribution, what we do is we start with the tallest bar and then we draw the frequency curve like this. We do the same thing on this side. We draw that. And we look at the shape of the distribution. Is it skewed to the left, skewed to the right, or it is normal?
It's normal.
It's normal. It is normal or symmetrical, right?
Yeah.
Symmetrical, or what is it called? One more name?
Bell something.
Bell-shaped. Yeah, we got it. Bell-shaped. You just have to write one. If you write all, I'll be happy. Let's go to next one here. Here is the tallest bar. And then from there, we draw the curve like this, all the way up to there. This side, here it is, and then we come down. So in what direction is the tail more stretched? To the left or to the right?
This is the left.
To the left. So that means this data is skewed to the left, right?
Yeah.
Skewed left. Skewed left. If it is skewed to the left, the other name is it is more towards the negative numbers. So we say that it is negatively skewed. Okay, we also say negatively skewed. Any question on this one? Just say yes or no. Can you hear me?
Yeah.
No
No.
question.
No question on this? No question, or there is a question?
No.
No.
Question. Okay.